Welcome to this video on displacement time graphs. Let's understand and interpret displacement time graphs. Here we have a vehicle that is travelling north from A to B to C. When it reaches C, it turns around and travels south, C to D to E to F to G. What we're going to do first of all is find the velocity of each of these segments. So we're going to find the velocity of A to B. We're going to find the velocity from B to C. We're going to find the velocity from C to D. We're going to find the velocity from D to E. We're going to find the velocity from E to F. And finally, we're going to find the velocity from F to G. Now, let's first of all start by looking at the segments C and D and E and F. The lines on the graph are flat, so this would indicate there has been no change in displacement. So if there is no change in displacement, then there is no velocity. So straight away we can say that the velocity from C to D is 0 kilometers per hour, and the velocity from E to F is 0 kilometers per hour. Right, let's now take a look at the velocity between A and B. To find the velocity between A and B, we have to work out the gradient of the line AB. To work out the gradient of a line, you find its change in y for its change in x. So I'm going to just label my displacement axis as y because it's the vertical axis, and I'm going to label the time axis x because it's my horizontal axis. So velocity between A and B is the change in y, which is 20 kilometers, divided by the 1 hour. So the velocity from A to B is 20 kilometers per hour. The velocity from B to C, we can see goes, the displacement at C is 140 and the displacement at B is 20. So if we do 140 minus 20, that will give us our change in our displacement, and we divide that by our time, which is 1.5 hours, which is 80 kilometers per hour. Now let's look at the velocity between D and E. We can see that the line between D and E is sloping downwards. This is showing us that the car is now travelling south. So its position from, let's say, home, which was at 0, which was at the start of the question. So the displacement, the change in displacement from D to E is 120 minus 140, noticing that there is a negative change in displacement because the car is travelling south. That's happened over 1 hour. So 120 minus 140 is minus 20, divided by 1 is minus 20 kilometers per hour. Okay. Finally, let's now look at the velocity between F and G. We can see that point F is 120 kilometers from home, and G is at home. So the change in displacement is 0 minus 120, and that takes place over 3 hours. So that would be minus 40 kilometers per hour. Let's now find the average velocity. The symbol for average velocity is V bar. To calculate the average velocity, we find the total displacement and we divide that by the total time. Well, our total displacement is the change in displacement from SG to SA. S here is the symbol we're using for displacement. So SG is the displacement at G, SA is the displacement at A. And we calculate the difference between the two of those. And as we can see, there is no change in displacement between the start at A and the finish at G. But our total time is 10.5 hours. So we do 0 divided by 10.5, and we see that our average velocity is equal to 0 kilometers per hour. Let's now find the average speed. The symbol for average speed is V bar with mod brackets. So they're just vertical straight lines, call them mod brackets. And that is equal to the total distance divided by the total time. Now, when our car travels from A to B to C, it will cover a distance of 140 kilometers. And then when it travels back from C to D to E to F to G, it will also cover another 140 kilometers. Then we divide this by the total time of 10.5, and it gives us an answer of 27 kilometers per hour to two significant figures. Thanks for watching this video on distance time graphs. If you would like to learn more about this topic, such as discovering how to calculate the velocity from a curved distance time graph, then join us at kippersconsultancy.co.uk, where students and tutors will help you to build your confidence and access higher grades. Thank you. Bye.